All of the probabilities that we've seen so far have been for single events happening at a single moment in time. Tossing a coin, rolling a die, choosing a counter, spinning a spinner, a red car in a car park. But what happens if we've got multiple events happening at the same time? Well, actually, not very much changes. To find a numerical probability, we need to know two pieces of information. We need to know the number of times the event that we're interested in can happen, to give us the number on top of the fraction, and we need to know how many possible outcomes there are in total, to go on the bottom of the fraction. Now that's the key thing. If we can work out what all the possible outcomes are for any event, then we can find those two pieces of information. So even if we've got multiple events, as long as we can list in some way all of the possible options for possible outcomes, we can just do a bit of counting from there and write our fractions and find our probabilities. Downside is with multiple events, it can be a little bit harder to keep track of all the different possibilities. So we have to be careful, we have to be systematic with these things so that we can make sure we get all of the different options. Okay, first example. I toss 2 coins and record the outcomes. And we're going to assume that the 2 coins are different. They might be different coins, different amounts of money. They might be the same amount of money, but they are 2 separate coins. So the order of the coin tosses does matter. We need to record the event happening from the first coin toss and the event happening from the second coin toss. Now what we're going to do for any question like this is we are going to make a list in some way of all the possible options. Well, we could get, for example, a head from the first coin and a head from the second coin. Or perhaps we get a head on the first coin and a tail on the second coin. Maybe it's the other way around. Maybe we start with a tail on the first coin and then get a head on the second. Or maybe we get a tail on both coins, a tail and then a tail. They are the only possible options. And in fact, all of the possible options, we either get 2 heads or 2 tails, 1 head and 1 tail in either order. Now that we have all the possible options, we can look at individual probabilities for those. We could, for example, look at the probability that both coins give the same result. Well, that's either head and head or tail and tail. There are 4 possible outcomes, so the 4 can go on the bottom of the fraction. 2 of those are what we're looking at, head and tail, so 2 out of 4. We could also look at, for example, the probability of at least 1 tail. Well, there are 4 possible options again. How many of those contain at least 1 tail? Well, this one does. It contains at least 1 tail. This one does, and this one does. So 3 possible options. But by listing all of the potential outcomes, we've then been able to find our probabilities just by doing a little bit of counting. I toss 3 coins and record the outcomes. And again, we're going to assume that the 3 coins are different. Well, we need to consider all the possible outcomes. We're going to do exactly the same thing again. We're going to make a list. And this time it's even more important that we are systematic. We could get a head on all 3 coins. Maybe we get a head on the first coin, a head on the second, and a tail on the third. But there are more options where we only get 1 tail. So we get no tails, 1 tail. We could have head, head, tail, or we could have head, tail, head, or we could in fact have tail, head, head. We could have the option where we get 2 tails. So maybe it's head and 2 tails, or maybe it's tail, head, tail, or maybe it's tail, tail, head. 3 different ways of having 2 tails. So no tails, 1 tail, 2 tails, and then we could have the option where we get all 3 tails. 1, 2, 3, 4, 5, 6, 7, 8 possible options overall. Now if we want to find out probabilities, we know that we're out of 8 every time. We just need to do a little bit of counting. So maybe we want to work out the probability that they are all the same. Well, that's 1, 2 out of 8. Maybe we want the probability that there are at least 2 heads. Well, that's 1, 2, 3, 4 out of 8. Or maybe we want the probability that there are exactly 2 heads. Well, that's just 1, 2, 3 out of 8. And again, we've been able to work out our probabilities fairly easily because we first of all started with a list of all the possible options. Now, sometimes a list might not be the easiest way to work out all the possibilities. For the 3 coins example, there were 8 different outcomes. And that was reasonable to write in a list, but imagine that there are lots more than that in terms of outcomes, that there are more like 20, 30, 40 outcomes. Trying to list them all would be quite difficult, but we still need to consider all the possible options. So we just need a different way of setting out our answers. Consider 2 fair 6-sided die. Imagine rolling them both and adding the scores. So we roll a die, we get either 1, 2, 3, 4, 5 or 6. We roll another one and we get either 1, 2, 3, 4, 5 or 6, and then we add the 2 scores together. There are then going to be a lot of different options. So what we're going to do is, rather than a list, we're going to set up a table. And that table is going to look something like this. So we've got the possible options for the first die along the top. 1, 2, 3, 4, 5, 6. And then we've got the options for the second die down the side. 1, 2, 3, 4, 5, 6. And inside this table here, we are going to fill in the possible outcomes. If, for example, we get a 1 on the first die and a 1 on the second die, we're then going to add those together and we're going to get a total of 2. A 2 and a 1 will give us 3. A 3 and a 1 will give us 4. A 4 and a 1 will give us 5. A 5 and a 1, 6. And a 6 and a 1 will give us 7. A 1 and a 2 will give us 3. A 2 and a 2 will give us 4. A 3 and a 2 will give us 5. And as if by magic, we've filled in the whole table. Now that we've got all the possible options, well, first of all, a piece of terminology. The lists from before, with the outcomes from the coin toss, this table here, they are both examples of what we're going to call sample spaces, which is just a really fancy way of saying list of all the possible outcomes. So if we're talking about sample spaces, just a list of all the possible outcomes. Now we have our list, now we have our complete sample space, we can find some probabilities. Because once again, it's just a case of counting up how many of the outcomes are what we're interested in and how many outcomes there are in total. Well, first of all, we need to know how many outcomes there are in total. Well, there's 1, 2, 3, 4, 5, 6, and then 6 rows of that, giving us 36 outcomes in total. We could find, for example, the probability that the total is more than 10. Total is more than 10. Well, there's 36 options in total, so we're out of 36, and we need to then count up how many of those are more than 10, and that's strictly more than 10. 1, 2, 3. So 3 out of 36. We could find the probability that the total is even. Well, we're out of 36 again, because there's 36 options in total. We just need to count up how many of those are even. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 36. And again, we've been able to work out some fairly simple probabilities just by having a complete list of all the possible options, presented as a table this time, and then by counting up how many options are what we are interested in.